Welcome back, dear students. In this class we will discuss about few problems on by Rayleigh's method. Okay, now see, in a previous slide we come to know that what are the procedures to follow the Rayleigh's method. The first one is identify dependent and independent variables, which is dependent, which is left hand side, and which is right hand side, that you need to identify. And after that, write the dimensions of each and every that parameters given in the problem. That it might be your dependent or independent. Write all the dimensions, and after that write the form of Rayleigh's equation. Write the form of Rayleigh's equation, and after that substitute the dimensions in the equations. After that, equate the powers, calculate A, B, C, D, then resubstitute in the given equation. End of the problem. Okay, now the problem is given here. You can see the time period T of a pendulum depends upon the length L of the pendulum and acceleration due to gravity. Derive an expression for the time period. Here they are telling that this time period is depends on, means dependent. First step is what? Step 1 is what? Dependent variable. Which is the dependent variable? Time is a dependent variable. I will call it as a T is a dependent variable which comes in the left hand side. This is LHS, right? Now, and it is depending on what? It is depending on the length. It is depending on the length we will call it as a L. And it is depending on what? It is depending on acceleration due to gravity, that G. This is a comma acceleration due to gravity G. It is depending on that. Therefore, these two terms I will write in the right hand side. First step is over. I identified the dependent variable and independent variables. Then the second step, what it says? Second step is write down the dimensions of the given parameter. Now time represented as a T, and the dimension is capital T. This is the dimension of time. And the second one is, second parameter here given is length. This is the length, and we'll call it as a L, L symbol as a L, and the dimension for this length is capital L. And the third one is acceleration due to gravity. Acceleration due to gravity, that symbol is G. And gravity acceleration means what? Meter per second square. You can write here meter per second square. Meter means what? Length, and second means time it is. Therefore L T raised to minus 2. This is the dimension. Okay, second step is over. I wrote the dimensions of all the parameters, right? Now I will go to the third step. Step 3. Now I will write the form of Rayleigh's equation. Rayleigh's equation is what? T is a function of L and G. T is a function of L and G. Now you can write it as f function. We will remove it. We will consider a proportionality constant L into G. And here power A, power B, you should not forget. Okay. This is what the Rayleigh's form of equation. F of function of first parameter power A, second parameter power B, like that. How many parameters will be there? That many A, B, C, D you will write. But here only two parameters, therefore A and B. Now I will write here A and B. Right? The step 3 is over. Now step 4 is I have to write the dimensions of this one. T dimension is capital T, and this K dimension it won't have because it's a constant, and L dimension is capital L to the power A, and G dimension is L T raised to minus 2 to the power B. In this problem I will solve it very clearly. K, L raised to A, and L raised to B, and T raised to minus 2B. Right? These many, and here T is there. Right? This is what we done, and now we need to go to the step 5. In this step 5 we need to equate the powers. First look at here. we don't have any, actually the fundamental this one parameters are m, l and t, but we have only t, means here I will write m to the power 0 and l to the power 0, m to the power 0, l to the power 0 and t to the power 1, right? Now I will equate the things. Then here m is there, and in this side in RHS we don't have any m term, therefore leave it. Then I will come to the power of L. Power of L, LHS side 0 is there, and power of L here A and another one plus B is there. A plus B is the power of L, right? Now I will come to the power of t. Power of t here in LHS side 1 is there, and in RHS side t is minus 2b. From this I can write b is equal to minus 1 by 2. I got a value of b equal to minus 1 by 2. This b equal to minus 1 by 2 I will substitute here, then I will get a equal to plus 1 by 2, right? Now over a and b we got. Now going to the step 6, I will resubstitute back into my equation. That my equation is t equal to k into l raised to a and g raised to b. See here, t equal to k into l raised to a is a 1 by 2 and g raised to 1 minus 1 by 2. This I can rearrange and write, that is k into l by g raised to 1 by 2. This I can represent it as k into root l by g. This is your time over, right? Now I don't explain, no need to repeat it, because you can just rewind the timeline and go back and see the once again the problem. Okay, now just I can tell here the step 1 LHS RHS are identified, step 2 T L G dimensions are written, and step 3 the form is written, and step 4 the dimensions are substituted, and step 5 powers are equated, then resubstituted back over, right? Going to the second problem. Here the second problem is find an expression for drag force. Here the drag force on smooth sphere of diameter d moving with a uniform velocity v in a fluid of density rho, dynamic viscosity mu, right? Here something very interesting it is. Here you need to identify, they want to find the expression for drag force. They want expression for drag force, means the first step I will identify drag force F as a LHS side, and the other things are what, diameter d and moving uniform velocity v and density rho and dynamic viscosity mu. I will consider them as a independent variables, right? Then in the step 2 I have to write all the dimensions. Then coming to F is a force means mass into acceleration, mass means m, acceleration is meter per second square, l t raised to minus 2. F is over. Then diameter is a length, diameter means what, that is one type of length, therefore l is a dimension, and velocity is a meter per second, meter means length, per second means t minus 1. Then coming to rho is a density, kg per meter cube, kg means it is a mass, meter cube means l raised to minus 3. Then coming to viscosity unit is Newton second per meter square, Newton means m l t raised to minus 2, Newton second means t divided by meter square is a l square, therefore the answer is m l raised to minus 1 t raised to minus 1. This is a dynamic viscosity over. We had a 1 2 3 4 5 parameters. 1 2 3 4 5 parameters. I wrote the dimensions here, therefore the second step is over. Now coming to the third step, I have to substitute back. The form of the Rayleigh's equation is F is equal to a function of diameter, velocity, density and viscosity. Now f equal to what? F equal to some constant k times sorry, here a b c d, the powers, k times d to the power a, v to the power b, rho to the power c, and mu to the power d. I got f equal to this much answer. This is your step 3. I got the form. Now I need to substitute the dimensions. m l raised to minus sorry m l m l t raised to minus 1, this is not there, m l t raised to minus 1, sorry minus 2, it is minus 2, that's equal to k into l raised to a, this is l t raised to minus 1 to the power b, then rho means what? Rho is m l minus 3 to the power c, then viscosity m l raised to minus 1 t raised to minus 1 to the power d. Am I right? Yes. Now this is O. Now I need to equate the powers. Powers means what? First, power of m. Power of m, this side it is 1, LHS side it is 1, and this side powers are come here, then m to the power whole bracket c means c is there, that is your c, m power c, and l to the power of minus 3c, therefore m power c is there, that I will write, and here m power d, therefore c plus d. Then I will equate the powers of L, and LHS side it is 1, and this side RHS side A plus B, see this is A power and this is the L power B, then coming to here L to the power of minus 3C, then L to the power of minus D, therefore minus D. This is the power of L. Then I will come to power of t. Powers of t is here minus 2 is equal to, and t to the power of minus b, and here t to the power of minus d. Right? We got this much. Now these three equations are there and four unknowns are there. Therefore it is very difficult to get the a, b, c, d values. Therefore here we need to consider one assumption or one power, we need to keep it as it is. Means I will express this a in terms of d, and I will express b in terms of d, c in terms of d, then d is always a d. D is already in terms of d only, that a, b, c I need to express in terms of d. Right? Now I will express first parameter, which is very easy to express, that c. Here it is. This c equal to what? C equal to 1 minus d. C equal to 1 minus d. I got it. Very easy, right? Over. Means in place of c I can write 1 minus d. Right? Now coming to this b. B I can express very easily. This I will rewrite 2 equal to b plus d. Then b equal to 2 minus d. Therefore I got b equal to 2 minus d. See, b is expressed in terms of d and c is expressed in terms of d. Now coming to a. This equation I will rewrite here, that a is equal to, keep it a and send all of them that side, that is 1 minus b plus 3c plus d. Now 1 minus b means what? B is a 2 minus d, therefore minus 2 plus d, take care of the bracket, and plus 3 into c. C is a 1 minus d, therefore 3 minus 3d plus d. You substitute in the bracket and simplify it. I am doing it directly. Then now here 1, I will do it here only. 1 minus 2 is a minus 1. Minus 1 plus 3 is a 2. This is the 2. Okay, na? Then number is 2 and d here, and minus 3d is a minus 2d. Minus 2d plus d is a minus d. That is 2 minus d. Then I got a as a 2 minus d. See, I expressed A, B, C, D in terms of D. Any difficulty? Right? Now I will go to the sixth step. I will substitute back. Then what is that? The main form. The main form is that your unknown is what? F is K d to the power A and v rho to the power B rho to the power C and mu to the power D, right? Now K, what is D? D is a D. What is A? A is 2 minus D, 2 minus D, and V to the power B. B is 2 minus D, 2 minus D, and rho to the power C. C is a 1 minus D, 1 minus D, and mu is a directly it is. Then F is F, then F equal to K into this. I can write it as d square into d power minus D, then v square into v power minus D, then rho into rho power minus D, then mu power D. Minus D means what? They will come down. They have to come down. Therefore K D square V square and rho will be as it is, and then this D power D and V power D. Okay, this comes down, this comes down, this comes down. Rho power D and mu power D will be here. Then we will get K into D square V square rho, then mu by D V rho to the power D. This is exactly the equation, but this D we don't know, therefore we can say that it is a function of, it is a function of, then what is that? Rho D square V square rho, K D square V square rho into a function of mu by dv rho. This is the final equation, right? Now we'll go to the next question. Next question, I will give you a homework, then you can solve this one. I will give a hint. Find the expression for the power P developed by a pump when P depends upon head H, discharge Q and specific weight W. Okay, specific weight W. Now here they are saying that this power is a function of head and discharge and gamma. Okay, this first you write the power is always Newton meter per second. Okay, this is a Newton meter per second, and H is head and Q is a discharge, and gamma is specific weight. I only will solve, don't worry. Okay, now you all know this one. Then first identify which is your left hand side, that is the power, and right hand side function of HQ gamma. Now what is the power? Write the dimensions of power. Power is Newton meter per second. Newton means mass into acceleration, and meter means length, divided by second means time. Therefore m L square t raised to minus 2, and this minus 1 comes to the top. This is 1 and comes to the top minus 3. This is power P. Then the second one is a head H, that is head is measured as a meter and that is a length, therefore the dimension is L. Then discharge Q, discharge is measured as meter cube per second. Meter means it is a length cube, and t raised to minus 1. Okay, then we have a specific weight is Newton per meter cube. Newton is m mass into acceleration into divided by L cube. Then this becomes m L, and this is a 3 comes to minus 3 and minus 2, it becomes minus 2 t raised to minus 2. This is your gamma. Okay, now we will substitute back into the equation. The Rayleigh's form of equation is P is equal to a function of h to the power a, q to the power b, and gamma to the power c. Sorry, here the symbol is given w omega, w it is given, but I am considering gamma because I have a practice of a specific weight gamma. You also have that practice, therefore we are considering gamma. Okay, now gamma to the power c, then the power dimensions is m L square t minus 3, m L square t minus 3, that equal to f I will replace and I will write a k, then h is a length to the power a, and q is a L cube t minus 1 to the power b, and this is gamma I will directly write m L minus 2 t minus 2, m L minus 2 t minus 2 to the power c. Then I will equate the powers. Then power of m in a left hand side it is 1, and here the power of m is here directly m to the power c, therefore c is equal to 1. Then power of L, and left hand side power of L is 2, and this side it is first a, and this side it is 3b plus 3b, and this side it is minus 2c. Okay, these are the powers of L. Then coming to power of t, then left hand side it is minus 3, and here power of t is minus b and minus 2c. Now in this equation minus 3 minus b minus 2 into c means what? It is 1. Therefore minus 3 equal to minus b minus 2. Then 3 equal to b plus 2. Then b equal to 3 minus 2 1. Then b equal to 1 we got. Now substitute this b equal to 1 and c equal to 1 into this equation. In this equation 2 is equal to a plus 3 into b equal to 1 and minus 2 into c equal to 1. Then I got 2 equal to a plus 3 minus 2. Then 3 minus 2 is 1, and 1 comes this one minus 1, therefore a is equal to 1. Now I got a equal to b equal to c equal to 1. Then going to the equation, p is equal to k into h to the power 1, q to the power 1, and gamma to the power 1. Therefore the equation is p equal to k h q gamma is the formula. Right? Coming to the next problem, that is efficiency neta of the fan depends upon the density rho, dynamic viscosity mu, and angular velocity omega, diameter d of the rotor, and discharge q. Express neta in terms of dimensionless parameters. Okay, now we'll go ahead. Then neta is given, therefore neta is a function of what? Neta is a function of first density, then dynamic viscosity mu, not bracket. Okay, dynamic viscosity mu, then we have a angular velocity omega, and diameter d, and discharge q. Okay, these many parameters are there. Neta is depending on all of them. Now we will write the dimensions of them. Then neta, it has a dimensions nothing, m raised to 0, l raised to 0, and t raised to 0. It don't have any dimension. Neta is a efficiency is a fraction. Now mu is, I will take it directly, you should work out. Okay, then what is the mu? Mu is L m L t minus 1 minus 1, right? M L, sorry, m L minus 1 t minus 1. Then coming to omega. Omega is a angular velocity. Omega is angular velocity. Therefore, the angular velocity dimension is what? T minus 1 per second it is. This is the unit is per second. Therefore, T minus 1. T minus 1. Then coming to diameter. Diameter is the length L, and discharge Q. Discharge is meter cube per second. L cube minus T minus 1. L cube T minus 1. Right? Now we got all of these dimensions, and we'll write the Rayleigh's form. Rayleigh's form is what they want, neta. This neta is equal to k into rho mu omega, k into rho mu omega, and dq. Then the powers will be a, b, c, d, e. 5 powers are there, right? Now I will write all of them. This is m raised to 0, l raised to 0, t raised to 0, and k is k, and rho is what? I did not write here rho, right? Then here rho is there. Rho, the unit is kg per meter cube, kg per meter cube. ml raised to minus 3, ml raised to minus 3 to the power a, and ml raised to minus 1, t raised to minus 1 to the power b, and omega is a t minus 1 to the power c. Then diameter length to the power d, and then discharge L cube t minus 1 to the power e, right? Then powers I have to equate. Power of m is 0 is equal to a. This power is a, and this power is b, a plus b, and over this is a plus b. Then power of L is power power of L, this side 0, left hand side 0, and right hand side minus 3a, coming to here minus b, coming to here plus d, coming to here plus 3d or 3e. This is power of L. Then I will write power of t. Power of t is left hand side 0, and coming to here minus b, and here minus c, and here minus e. This I got. But here again the difficulty is what? The difficulty is we have 3 equations and 5 unknowns. 3 equations, 5 unknowns. Therefore, I have to consider arbitrarily 2 unknowns as it is we need to keep. 2 unknowns I will keep as it is, means D and last term E. D and E I will keep it as it is, and rest all other A, B, C, all other powers I will express in terms of D and E. Now coming to D and E. Okay, if I take D and E, see here it becomes very complicated, because here there is no D, and in the first equation there is no D. Therefore, I will choose this one as a B and E. I will start expressing them B and E. Okay, because directly I can express this A. Now look at here. This directly I can express this A is equal to what? Minus B over. The A is expressed in terms of B. Then coming to the third equation, this C I can express how? C. C is equal to what? C is equal to this C will come this side, plus C equal to minus B minus E. C. then C is expressed in terms of B and E. Over A is there, B will not express, and C over, and now D we need to think. Come to this equation. Here 0 is equal to minus 3. A means what? A means here minus B. Minus B. Minus B as it is, plus D. We want a D only, therefore D as it is, and plus 3 I will keep it as it is. Now what is this? Minus plus 3b minus b plus d plus 3e. Then 3b minus b is the 2b plus d plus 3e. Then I can say that d is equal to what? Minus 2b minus 3e. This is your D formula. Once again I will write all, okay, so that you will understand. What is the A is equal to? A is equal to minus B. A is equal to minus B. B I did not transfer it. C, yes, C is equal to minus B minus E. Okay, minus B minus E. What about D? Yes, D is equal to minus 2B minus 3E. Minus 2B minus 3E. Then what is E equal to? E I did not transfer, therefore E is equal to E. Then I got all of them. Then coming to the original equation. What is that original equation? This, that is neta is equal to K rho mu omega, K rho to the power what? A minus B, rho to the power minus B, and mu to the power what? Mu to the power B is here, therefore B means it is B only. Then coming to omega to the power C means what? Minus B minus E, minus B minus E. Then coming to omega next D, diameter to the power D. Then D is equal to here minus 2B minus 3E, minus 2B minus 3E. Then E, that the last term is Q to the power E over. Now I will write K, this E to the power rho to the power minus B, mu to the power B, then omega to the power minus B, omega to the power minus E, then D to the power of minus 2B, D to the power of minus 3E, Q to the power of E. Now we will make all E powers one side and B powers one side. Then K, this is rho to the power B, mu to the power B, and this is the omega to the power minus B, means omega to the power B comes down. This is over. Now jump to this one, D to the power minus 2B plus 2B comes down, and this is over. Okay, this we will put one bracket. The another bracket is left out, powers is. Then this is omega to the power E comes down, and this is a D to the power of minus plus 3E, and Q to the power E. Okay, minus powers will come down and plus powers will be in the numerator. Now K into mu by rho omega d square to the power B into Q omega dq to the power E. Then I can say that K is a function, K into a function of mu by rho omega d square into Q divided by omega dq. This is neta formula, right? Now coming to the next problem. Here the resisting force R is of a supersonic plane during the flight can be considered as a dependent upon the length of the aircraft L, velocity V, viscosity mu, and density rho and bulk modulus k, and express the functional relationship between these variables and resisting force. Then see, a resisting force is r is a function of, they said that the first function is the length and velocity, dynamic viscosity, dynamic viscosity and air density, and then bulk modulus. Okay, na? This is there. These you need to first you write all the dimensions, and after that you will get, I will give the final answer, you just cross check it. Okay, na? Then here this r is equal to a rho l square v square is a function of mu by rho vl into l g by v square. Sorry, lcl. Mu divided by rho vl into, sorry, this is not, k divided by rho v square, k divided by rho v square. This is the function. You will get the answer, this one. Check it. Okay, again this, there are 5 variables are there here, just like a previous problem. Here also we had a 5 variables, the same thing it will go. Okay, and you need to express the in terms of 2 powers, right? Oh, thank you very much.